In this video, we're going to take a quick look at Emonitor's Real-Time Analyzer Utility. Also called the Emonitor RTA Utility, this utility gets installed automatically with Emonitor version 4.0. But you can also install it as a standalone utility on any other workstation, whether Emonitor is installed there or not. The only other component it requires is RSLinks Classic Lite. Let's take a look at the RSLinks Classic setup to make sure we understand what's required. For the Emonitor RTA utility to talk to our 1444 modules, we simply need a driver, either an Ethernet driver or an Ethernet IP driver, that allows us to get to our Dynamix 1444 modules. In this case, I've got an Ethernet driver configured, and it is pointing directly to my Dynamix 1444 IP address. So once you've got the driver set up, you double check in the RSLinks browse tree to make sure that you can navigate to your Dynamix 1444. You make sure that it has been properly identified as a Dynamix 1444 and actually shows an icon here and not a generic icon, and that it is responding on the network and doesn't have a red X through it. So once we know that the module is successfully communicating and identified with RSLinks Classic, we can simply exit out of that particular application. So let's jump into the Emonitor RTA utility and have a look. When you launch the Emonitor RTA utility, it comes up to a basic window here where you have two options. You can define a new series of one or more 1444 network connections, or you can go to the File menu if you have previously saved a setup, and you can go to the Recent Files option and open a saved configuration. We'll take a look at that in a second. Let's take a look at how we actually add new modules to this network. So we right-click on Network, we say Add Device. This opens up the RSWho window from Links Classic. Now we can browse down to the driver where we will find our Dynamix 1444 module. And when we click OK, that module is now added to the list. Now you can add as many modules as you want to this list and then save them for future reference and easy configuration when you go into RTA the next time. So you can do it once and then reuse that. And you can share that file with other users if you have multiple people who want to use the utility. So once I've got a module here, I can right-click on it and say View Device Data. At this point, the RTA utility will query the module for the available measurements that it is currently configured to provide. It will only show you measurements that you can actually select and get data from. So in this hierarchy tree on the left-hand side, these are the available measurements on this particular 1444 module that are currently configured. So even though there are 8 bands available on the 1444 module per channel, only 4 of them are showing right now because I've only enabled 4 on this particular module. To start viewing data, you simply need to check the box that you're interested in looking at. So if I want to see a spectrum, I'll click on Channel 0 Spectrum, and it'll immediately begin plotting a spectrum for me in real time. Now on a spectrum plot, I can turn a cursor on, and when I turn the cursor on, you can see I get a legend box here, and I can reposition that as desired. I can drag the cursor to a specific peak, and when you get it close, you can use the arrow keys, right and left arrow keys, to position the cursor exactly where you want it. I can also draw a box. You see how it's auto-scaling here. I can draw a box using the left mouse button, and I can zoom in on a particular area. And I can zoom in on any area. It could be just a small frequency band, or I may just want to zoom in on a subset, maybe up here to around 25,000 CPM. And that'll spread the spectrum out for me. But you also notice that this axis here is now locked on the scaling. But this allows me to see the individual peaks more clearly and zoom in on any particular part of interest that I would like to inspect more closely. To get back to the original plot, I can click on Auto Scale, and it takes me back to the original view. Now it will show me the units that I have configured on the module by default. So I am in peak signal detection. I'm currently looking at it in inches per second and CPM. Now I can actually click these little tags and it will recalculate the amplitudes based on that change. So I can look at it in Gs, microns, millimeters, millimeters per second squared, meters, and eventually I'll get back to inches per second. I can also look at it in peak to peak if I want, and it will rescale accordingly. RMS is another option, and then back to peak. As I mentioned, it'll show you by default the specific parameters that the module is currently configured on this particular channel. If I want to look at something other than CPM, say orders or hertz, I can also do that as well. Now, if I go to hertz, you can see it rescales to hertz. But if I want to look at orders, I do have to have a speed input currently configured. I do not have a speed input on this particular module right now. So if I click again to go to orders, it will tell me that I'm not configured for speed, and I need to set that before it can show me the orders scaling on the bottom. So it'll go back to CPM after that. And that's the basics of the spectrum measurement. So let's take a look at the waveform. We have similar options here, right? And by the way, you can freeze these plots by clicking the pause button so that the plot stops updating. And again, you can turn the cursor on, and it opens up the cursor legend here, and you can move the cursor wherever you want it using either the arrow keys or the mouse drag. You can zoom in on the time waveform just like you can on a spectrum by left click and drag. And then you right click and choose auto scale to return to the default view. So pretty straightforward. Now if we want to look at the discrete values, it will stack these in a strip chart format. So the first thing we'll want to do is we'll want to click the play button to resume streaming the data, and we'll pick an overall and maybe just click the bands button, and you can see it stacks all of these, and we'll begin populating these trend plots from the right hand side. And again, we can turn on a cursor. It opens up a legend showing each of the parameters I have selected, and I'll just drag that cursor over to here to where the new data is coming in, and you can see now my magnitude or amplitudes here are being reflected on each of these measurements. Now I can add a spectrum to this, and it will put that on the bottom, and it will take the entire bottom pane. If I add a time waveform to this, it will try to tile these in a way that I can see everything. Now at some point, if I select a sufficient number of parameters to trend, I will have to start scrolling the display in order to be able to see these other trend plots. So the data that we're plotting here by default is coming from the Dynamix 1444 live data buffer. The resolutions and all of the filtering is dictated by our configuration on the 1444 module. Now the module has another buffer called the demand buffer that gives me the ability to specify on demand some additional configuration parameters such as resolution and sample rate. So it may be, for example, that the spectrum that I'm looking at here is a 1600 line or approximately a 1600 line spectrum. And let's say, for example, that I'm looking at happen to be monitoring something like a gearbox, and with a 1600 line spectrum that I'm collecting on a normal schedule, I don't have sufficient resolution to be able to diagnose something like a cracked gear tooth problem. So in order to get sufficient resolution for that kind of thing, I need to be able to take advantage of the very high resolution capabilities of the Dynamix 1444, but I may not want to change the fundamental configuration of the module. I just want to take a quick look at a higher resolution, and that is what the demand data buffer on the 1444 allows you to do. So let's take a look at how RTA allows us to access that data. So the first thing I will do is I will pause the current plot, and that activates this little lightning bolt here. And you can see the mouse help says acquire and plot demand data. So when I click the lightning bolt, it opens up a window and allows me to add some additional configuration here that I can request on demand. Now for simplicity, I'm only going to select data from channel 0. That will show me all 4 channels if I so desire, but I'm going to say I would like samples of 4096. I'm going to choose FFT lines of 12,800, and I would like to see that in peak signal detection. So if you wanted to copy this particular set of configurations to the other channels, you could use this copy function to do that. But you do need to activate waveform and FFT, or at least one of them. in order to do that copy. Right now we're just doing channel 0, so we'll click Get Demand Data. Now because this data isn't sitting in the buffer already, because it didn't know what the configuration was going to be until we just told it, it must collect this data. So depending on the resolution that we've asked for, it may take a few seconds for that data to come back to us. Now when these plots finish populating, we will see a snapshot of very high resolution data. And this can be full screened as desired. Now since the cursor is turned on already, we have the zoom function, same as we do in the other spectrum plots, so I can zoom in. It's a critical function to have when you're dealing with data this high of resolution. So you can really get into these individual peaks. So I'm currently looking at a snapshot of the data in high resolution. I can click this play button here in the upper left-hand corner, and the demand data will resample at that high resolution as fast as it is able to collect it. Keep in mind though, at a much higher resolution it may take longer for updates than it does on the standard lower resolution update. But that is the demand data option in the RTA utility. I mentioned earlier that once we've added our 1444s to this list, we do have the ability to save that, and then we don't have to keep adding those every time we open the RTA utility, and it creates an emo file. Now you can see I've got one here already called feed pump. So if I wanted to open that particular one, I can simply say file open, and I can pick it from the list. It's going to have to close the current one that I'm in right now. I'm not going to save those changes, and it will load the feed pump configuration, which in this case happens to be the same module that we were just looking at. But if I had a couple of dozen modules, say, already configured here, I wouldn't have to go back and re-add those. And whatever displays that I had opened, when I saved the file, it will open those displays. So as you can see, it's populating the overall on band 1 on channel 0, and it's giving me the spectrum and waveform. And the reason for that is the condition of the live data screen when I did the save. So it takes me immediately back to that particular view. So that's very handy. And that is about all there is to the Emonitor RTA utility. I hope you found the video helpful. We'll see you in the next one.